Hello again. Lesson 5, leading on from the plate boundary lessons. I've covered divergent, convergent collision zones, which is a version of convergent. We're kind of running now towards the end of this, the last two presentations. So this one will look at conservative plate margins, relatively short video, lesson 5. Again, just using the syllabus, it does link into this, so 1A, 1B. I mean, we're not talking about intraplate things here. So, and then there's a little bit of this kind of recapping, very much 1.2B, and sort of like slightly going into the earthquake aspects, which we'll look at in subsequent lessons. So there are two basic movements with a conservative margin. No volcanoes, no magma upwelling here. And the classic ones that I would say probably a lot of you may have learnt about, let's say in year 7, 8 or 9, where the plates slide past each other in different directions. They're sliding past each other. This does occur. Caribbean, Haiti, parts of New Zealand experience this. And then over here, this is where the two plates actually slide in the same direction but at different speeds. This is moving faster than this plate here. This is the Pacific plate and this is the North American plate. Now, they both result in friction. Okay, we'll show this more on the next slide. So as these two plates, and these are going in opposite directions, but it has the same effect when they're going in the same direction at different speeds. That creates friction between the two plates. We get locking at some parts of that plate. Tensional forces build up significantly high in many instances. The rock snaps, jolts, jerks, whatever you want to call it. And there's a release of energy. That point at which it snaps is referred to as the focus, and that's where the magnitude is the highest, and the epicenter is always directly above it on the surface. The tensional forces here, as I said, can be quite significant. The earthquakes here are shallow focus, with I suppose about 5, 10, 15 kilometers of the ground, compared to the focuses with the convergent, which can be shallow, intermediate, or depth or deep. Sorry, I'm spluttering with my words here today. Apologies for that. The convergent, the destructive margins, and the conservative margins are where the magnitude of the earthquakes are the highest. Remember, you get earthquakes at all plate boundaries, but it's the conservative and the destructive margins where it's felt to be the worst. And this just reiterates that I've already talked about that. And this one here is a photograph of the San Andreas fault line. You can see you do get some specific like rippling, differential movement here, causing like sort of, I don't know, a little bit of compression, twisting. But you don't really go into any sort of detail at this level here. But sizable earthquakes. This is the San Andreas fault line. As I said, it's particularly long. It's over 1,000 kilometers long, and that's one of the reasons why it's difficult to predict when. You know you're living in an earthquake hazard area. You just don't know when. It's impossible to predict, certainly with current technology. And here we can see the differential movement here. So if you can look and see 6 centimeters per year, and that's 1 centimeter per year. So it's moving at 5 centimeters faster. Now this looks like California is nice and simple, but on the next map you'll see there are lots of fault lines. It's just the San Andreas one is the most famous one. And as I said, they're very long, stretching up California. No volcanoes. Look at this one here. Eventually Los Angeles will become an island off the Canadian coast. Isn't that bizarre? So there's Los Angeles. It's saying it's going to be up here at some point in the future. Nothing to worry about though for those of you living in Los Angeles. There's the complexity that I was talking about, and this really is a short video. So I would say you could probably get away with doing both, right? I would probably mention California, Haiti, because Haiti is often used as a case study. To be fair, so is New Zealand. I might put the two basic diagrams in there. Remember, key labels, so that's your quick go-to, just as like a survey. I need to know these words, and then your explanation in there. You could give specifics of an example, but relatively short example. And like all these things, remember to practice them. That's the way to become the expert. And remember, there's a lot of geographical language that's not used elsewhere. There ends lesson 5 on conservative boundaries. The last lesson of this set will be hotspots. Thank you very much for listening.